Hello friends, welcome to my channel. I am Devanjana and today I am going to discuss the first chapter of NCERT Science of class 9 and the topic is matter in our surroundings. Dear students, I have divided this chapter in 3 to 4 parts and in the last part of the video I will discuss the question answer and the doubt of this chapter. So my dear friends, in my videos, if you find any doubt, then please let me know it in the comment section. So without any delay, let's proceed to the chapter. So chapter 1, matter in our surroundings. My dear students, what is matter? Everything around us, like the food we eat, the water we drink, the air we breathe, these all are the examples of matter. The most essential matter in our life is the mobile phone, without which we cannot live a moment. The most dangerous matter right now is the coronavirus. All these are the examples of matter. But if we want to say scientifically, then we have to say that everything around us which possesses a mass and has a volume is called matter. So, to be a matter, it must have a mass and it must have a volume. And if anything possesses these two things, then that will be called a matter. Now, what is mass and volume here? Let's say that. Volume is the amount of space that something occupies. That means, if we consider this box, then this box has a certain amount of length. It has a certain amount of breadth and a certain amount of height. With these three things, we can find out the volume of this box. As it is a cuboid, so the volume of this box will be length into breadth into height. Now, if we want to find out the volume of a sphere, then we have to apply the formula of 4 by 3 pi r cube, where r is the radius of the sphere. Just like that, we can find out the volume of a cone, of a cube. But my dear students, can we find out the volume of an irregular object? If you know that how can we find out the volume of an irregular object, then please let me know it in the comment section. I will also discuss it in the next video of this chapter. But before that, let's know about the units of volume. The SI unit of volume is meter cube. But my dear friends, have you ever seen that in any bottle the marking is written in meter cube, 100 meter cube or 200 centimeter cube? Definitely no. We see the marking of milliliter. So 1 milliliter equal to 1 centimeter cube. That means if we go to market and buy a hand wash and we see the marking of 100 milliliter in that bottle, then that is the quantity of 100 centimeter cube. Why? Because 1 milliliter is equal to 1 centimeter cube and 1000 milliliter makes 1 liter. Now let's move to mass and weight. We often say that our weight, that means my weight is 60 kg, his weight is 40 kg, her weight is 30 kg. But my dear friends, that is not originally weight. That is originally our mass. What is mass? The total content of any substance is called mass. That means the measurement of how much content is there in a substance is mass. Now, if this box is 100 gram, that means the total content in this box, if we open this box, then the total content in this box and the cover of the box, everything makes 100 gram. That means if my weight is 60 kg, then total content in my body like the blood, the plasma, the organs, my hairs, my nails, all the things together makes a mass of 60 kg. Now my dear friends, what we think weight is originally mass. We often confuse weight with mass. We say that my weight is 60 kg, but that is not my weight, that is my mass. But then what is weight? Weight is the gravitational pull on any substance. That means if this is a substance, then the gravity of the earth is pulling this substance toward itself, and that makes the weight. Weight is originally mass into gravity. Now we can see here that weight is how much something is pulled by gravity, and SI unit of weight is kg meter per second square, which is originally the unit of force. If we go somewhere where the gravity is greater or lesser than earth, then we will find the weight will also be greater or lesser than that of earth. Why? Because weight depends on gravity. And that's why in moon, where the gravitational force is 1/6 of that of the earth, there the weight will also be 1/6 of that of the earth for any substance. Now my dear, we know what is mass, what is weight, and what is volume. Now once again, let's go through the definition of matter. What is this? Everything around us which possesses a mass and has a volume is called matter. Now matter is clear. Now let's move on to the next slide. The next slide is about Panchtattva. Many days ago, the philosophers, they used to think that all the things in the universe is made up of 5 basic elements, and that 5 basic elements are air, earth, fire, sky, and water. But in the modern days, scientists classified matter based on 2 things. One is physical properties and another is chemical nature. Now, many days ago, there were 2 thoughts. One said that matter is continuous and another said that matter is particulate. But which one is true? We can know it with a very common example. And that example is the soft and hot chapatis made by our mom. What she do to make chapatis? She take out some amount of flour. Now, if we see very closely to that amount of flour, we can look that flour is made up of many millions and millions of teeny particles, and it will be very difficult to separate a single particle from that amount of flour. And after a process, she made chapati. Now, my dear, can we say that this chapati is made up of many particles? Just like that, we can also take the example of cement, that means our home. What is it made up of? It is made up of cement, which is particulate. That means our home is also particulate. Just like that, all the things in the universe is matter, and all the matter in the universe is particulate. That means all the matter is made up of many billions and billions of teeny particles. And these particles may be atoms or may be molecules. In the book, there is an experiment. They took 100 ml of water and dropped a crystal of potassium permanganate in it. Now, they dissolved it very well and took 10 ml of solution from this beaker and poured it to the next beaker. And once again, they took 10 ml of solution from this beaker and poured it to the third beaker. And by this way, they repeated this process for 3 to 4 times. Now, what is the observation? We can see that in the last beaker also, there is a trace of pink color. That means there is some extent that may be very small, but there is some extent of potassium permanganate present in the last beaker also. Now, we can infer from this that this small amount of potassium permanganate is also made up of millions and millions of teeny particles, and these particles are getting divided in every beaker, and that's why we can see that the color is getting lighter, but still there is the presence of potassium permanganate in every beaker, though we divided it for many times. Now there is another example, another experiment also, but before that we will go through the nature of the particles. The first nature is particles of matter have spaces between them. The second nature is particles of matter are continuously moving. And the third nature is the particles of matter attract each other. So, we got three characteristics. 1. Particles of matter have spaces between them, particles of matter are continuously moving, and particles of matter attract each other. So, now let us explain the first nature, that is, particles of matter have spaces between them. My dear, we often drink a very cool homely cold drinks made by our mom. What is that? The salt, sugar and water mixture with a drop of lemon. That is very soothing in a hot sunny day, right? But one day, let us prepare it for our mother, because she also becomes very tired doing so many works at home and at their workplaces. And we can also perform this experiment while preparing that cold drinks. At first, we have to take a glass of water and then mark the upper level. Then we will add a volume of salt and sugar. That means a spoonful of salt or sugar, in fact both, in that water, and then we will dissolve it very well. And after that, we can see that the total volume of the mixture will not increase. Why? Though we added amount of salt, a volume of sugar in it, but still the total volume is not increasing. Why this is happening? Because this water is made up of many teeny particles, and these particles have spaces between them. And the salt and sugar, they are also particulate. These particles are getting adjusted in between these spaces, and that's why the total volume is not increasing. We can take an example of a classroom. Think if in a classroom there is 30 students and additional 10 students came, then will the school have to increase the boundary of the classroom? Definitely no. Why? Because the students of that classroom have enough spaces around them, and that additional students can easily get adjusted in these spaces. Just like this, we can also take this as the classroom and these particles as the students. And these particles have spaces between them, and the additional students can easily get adjusted in these spaces. And exactly this thing happened in this glass of mixture also. Now in the next nature, we can see that particles of matter are continuously moving. The experiment in the book is they took 2 glasses of water, one containing hot water and another containing cold water, and then they dropped a crystal of potassium permanganate or copper sulfate. Now what will happen? At first, that crystal will set at the bottom, and after that gradually the particles of that crystal will get mixed with the particles of the water. Why? Because the particles of the water and the particles of that crystal will be continuously in motion, and for that motion they will possess kinetic energy also. My dear viewers, what is kinetic energy? Technically we can say kinetic energy is half into mass into velocity square. That means a body, if it has a mass and has a velocity, then it will have a kinetic energy. Now we know that particles of matter have mass and they are also in motion. That's why they also possess kinetic energy. And this kinetic energy increases with the increase in temperature. Now let's see 2 homely experiment. Here we took a glass of water and then added a drop of dye in it. Now we can see how the particles of the dye are gradually mixing with the particles of the water. We can clearly observe how the particles of the dye are moving downwards, some particles are moving sideways, and some are moving upwards also. So, we can infer that all the particles of a matter are in a random motion, and this random motion of particles of a fluid is called Brownian motion. Just like the particles of the dye, the particles of water and the particles of every matter in this universe are in motion, and for this motion they also possess kinetic energy. We can also see that the particles of water and the particles of the dye are getting mixed with each other by their own, and this intermixing of particles by their own is called diffusion. Dear friends, here we took 2 glasses of water. One is hot water, that is marked here in the left side, and another is cold water. Now let's perform the experiment. We added a drop of dye in each glass. Now we can clearly observe that the dye in the hot water glass is mixing more rapidly than the dye in the cold water glass. Now dear friends, why this is happening? This is happening because when we heated the water particles absorbed the heat energy, and for that reason the kinetic energy of the water particle increased in the hot water, and the particles of the hot water have faster motion than the particles of the cold water. That is why the particles of the dye are mixing easily in the hot water than in the cold water. Next, the last characteristics, that is, particles of matter attract each other. If we take an iron nail and a piece of chalk, then which one will be harder to break? Of course, the iron nail. Now let us understand why this is happening. All the particles of matter attract each other, and this attraction is somewhere more. That means more for some substance, and that is less for some substance. And more is the attraction, that means more stronger the attraction is, the more harder the substance is to break. In case of iron, the force of attraction of the particles is very strong, and that's why we cannot easily break a substance that is made up of iron. This force of attraction is very high for solid. That's why solid tends to remain rigid. This force of attraction is somewhat lesser in liquid than in the solid, and in case of gas, this force of attraction is almost negligible. For that reason, gases does not have a fixed volume. They does not want to remain together. They always roam here and there randomly in the container. So we have to take a closed container to keep the gases. Now think, if we take a glass of water and try to cut the surface of the water, can we do it? No. Why? Because once our finger passes through that substance, through the surface of the water, then once again the particles of the water will reunite. This happens because of the force of attraction. But my dear friends, if we take a solid material and we break this, will it reunite once again if this comes together? No. Why? This is a question for you. In fact, this is a homework for you. You must let me know it in the comment section, and I will also discuss it in the next video. At last, we will know about diffusion. We already saw diffusion in the experiment, but now let us read the definition. Intermixing of particles of two different types of matter, that may be two or more than two, on their own is called diffusion. Now, particles of matter intermix on their own. We saw that in the experiment, or also we can take the example of incense stick. If we burn incense stick at any corner of a room, then we can smell the perfume from everywhere in the room. Why? Because the incense stick particles diffuse with the air particles in the room, and that's why we can feel the smell everywhere. So, what is diffusion? The intermixing of particles of two or more different types of matter on their own. This is called diffusion. Now, my dear friends, let us revise from the beginning what we have learnt. At first, we saw that everything around us which possesses a mass and has a volume is called matter. That means to be a matter, it must possess a mass and a volume. The example is the air we breathe, the food we eat, the stones, cloud, coronavirus, mobile, computer, everything. Now, the volume, it is amount of space that something occupies, that is volume. The SI unit of volume is meter cube. 1 milliliter equal to 1 centimeter cube and 1000 milliliter makes 1 liter. Next we know about the mass, that is measurement of how much content is there in a substance, that is mass. It is a fundamental property, that means it does not depends on anything. Next, the SI unit of mass is kg, and weight, it is how much something is pulled by the gravity. That means weight depends on gravity and it will be greater or lesser according to the gravitational force. The SI unit of weight is kg meter per second square. Technically we can say weight equal to mass into gravity. In the next slide we learnt about the Panchatattva, that is the air, earth, fire, sky and water. Here we can see these. Next we learnt that the modern day scientists, they classified matter in the basis of two things. One is physical properties and another is chemical nature. We also came to know that matter is particulate and performed an experiment with potassium permanganate crystal. There we took a glass of water and dissolved the potassium permanganate crystal and took some amount of solution to the next beaker and repeated this process, and in the last beaker also we saw that some extent of potassium permanganate is present. From this we can infer that matter is particulate. Next we came to know about the nature or characteristics of particles, which are particles of matter have spaces between them, they are continuously moving and they attract each other. We performed the experiment with water and salt and we saw there that the total volume will not increase though we added some volume of salt. Why? Because the particles of the salt is getting adjusted in between the particles of the water. So, we can infer that particles have spaces between them. Next we learnt about that particles of matter are continuously moving. We can drop a crystal of copper sulfate or potassium permanganate and we can see how gradually the particles of copper sulfate will get mixed with the particles of the water, although we will not stir the solution. From this we can say that particles of matter are continuously moving. We also saw that this movement of particle depends on temperature. As we increase the temperature, the kinetic energy of the particles will increase. And what depends on the kinetic energy of the particles? That means what depends on the movement of the particles? Of course, the diffusion. So, as we increase the temperature, the rate of diffusion will also become faster. Next, we came to know that particles of matter attract each other. We took an iron nail and chalk and then we know that breaking the chalk is easier than iron nail because the particles of the iron substance have more force of attraction between them. At last, we came to know about diffusion, which is the intermixing of particles of two different types of matter. So, this is all we learned from this video. Now, my dear friends, this video ends here. In the next video, we will discuss about the states of matter. You also have two questions for your homework which will be mentioned in the description box. And if you have any doubt regarding this video, then please let me know it in the comment section. I will definitely try to clear all the doubts. Till then, stay safe, stay healthy, and don't forget to subscribe my channel for more videos. For now, goodbye.